get something here that has three significant figures. At the end of the problem, we have the mass, now we have the moles. We take 2.120 grams divided by this number of moles. That'll give us our weight.
I'm sorry about that, folks. I didn't mean to do that. It was an accidental mouse click and away it went. All right, let's get started here. My internet connection's unstable. Let me see if I can fix that. Turn Wi-Fi off, and it should be better. Can you all hear me? Good.
Yes. Good morning.
Okay, good.
Yeah, we can hear you.
Good. Okay, we're going to continue on with, well, let me see. Let's make sure I share the screen first. That'd be fantastic. I'll do that. I'm going to continue with the review here. I think we're starting on the Module 9 material, if I remember rightly. And we're going to be just finishing this up today. If you have any test-related questions, you're more than welcome to ask them. You know, anything, does anybody have anything general that they want to ask right now about the test?
Is there any extra credit for doing the test earlier, or is there something I don't remember what it was?
No, not for doing the test earlier. For doing the sample module 7 to 12 test, this is the one we've been looking at. If you can complete this by tomorrow night,
okay,
with 80%,
yeah,
then you can get 5 points of extra credit, 5% of extra credit.
Okay, thank you.
All right. So the homework is all due tomorrow night too, 11:59 p.m. I'm hoping that people have been working through it, that they haven't just left it to the last minute.
Yeah, I got all that.
No, I'm not directing this at anybody in particular. That was a general statement. I feel like I've said that a million times, but I don't know. One of these days, I want to hold some sort of seminar or town hall type thing, just on the with one topic, and that's procrastination. I need to get a handle on why people leave things to the last minute, and I have a lot of trouble with that concept. But if anybody, again, if anybody wants to email me, talk to me about it. I mean, I would really like some insight. If anybody could, sincere insight, really. It would help me adjust. You know, if you can give me good reasons that I shouldn't have deadlines or whatever, you know, that's another topic I could discuss with people, because that, you know, then there wouldn't have to be any procrastination. People could do things whenever they wanted. So I'm wondering about that too. All right, so question 9. This is the first of the module 9 questions, as it turns out. So the kind of thing that you'll do here is, again, you'll use the dimensional analysis here, use the units to help you out. So the way I do it is just kind of the way I would do it on paper, and have liters of Cl2 here, and just put the unit in. Don't put any numbers in here. Let's go back to my modified flow chart here. So if you remember for module 9, I was using this as a flow chart. Yeah, something is stealing my thunder here. I'll see if I can improve the situation or not in a minute if it doesn't improve itself. Okay, so QA model, it's something's slowing my screen down here. But I really only want to write a couple of things here, so I'll come back to that in a minute. I'm hoping it'll prove itself. Sometimes it does that. Okay, so QA, mole A, mole B, QB. Now, if you look at what we want here and what we're starting with, we're not starting with moles and we're not looking for moles either. So we know that it's going to be based on this QA, QB situation here. So we know we have to do moles in the middle here. So we know that the first thing we're looking for is moles. So it'd be moles of Cl2 will go on top here. And then the relationship between them would be 1 mole is 22.414 liters. You can do the whole units of all of them first if you want to, but you don't have to. We're looking for moles of HCl, so that's going to be next according to the flow chart. That goes in space 3, and that's where we're at in the flow chart here, moles of B essentially. Moles of Cl2 goes on the bottom to cancel the moles of Cl2 we have in number 1, so that's for number 4. The relationship there is given by the equation. 1 mole of, let's see, we've got 1 mole of Cl2, we've got 2 moles of HCl, so 2 and then 1. And then what we want, according to this, is we need grams of HCl. So grams of HCl is going to go on top here, and then moles of HCl will go on the bottom. Anybody got any questions so far? Sometimes, as I said, as I think I've said in the past, sometimes people mistake lowercase L's for uppercase I's. It shouldn't happen if you're looking at the things and you have a little bit of chemical knowledge. You know it's not Ci2, you know it's Cl2, especially when you see the L here written in Times New Roman, which is very clearly an L with the serifs on it. Then you've got the, let's see, we've got the relationship there, 36.46 grams is 1 mole. All right, then you can do the math on it. And, you know, you can use the method that I've shown you in the past here of just multiplying across the top. So 42.5 times whatever's in 3 times whatever's in 5, and then dividing by anything on the bottom, which would be in this case 22.414, and I think that's it, ignoring the ones, of course. And I get 138. And if you look at the number of sig figs, we've got 3 sig figs we're starting with here, which means we'll need 3 sig figs at the end, 138 grams of HCl. Okay. So anybody got any questions about number 9? So if you remember, if you look at the study guide, this could be any conversion, liters to grams, grams to liters, liters to liters, grams to grams, any of those kinds of things. So you need to be prepared for all of them, which means you should practice all of them. That means doing this sample test a number of times to make sure you see all the different possibilities you could have. All right, anybody got any questions? When we're doing limiting reagents, we're only interested again in the reactants. And the focus when you're looking at the work here is to first of all find moles and then divide by the number of moles in the reaction equation. So for C, we know that 1 is going to be moles of C, is what we're looking for. Grams of C will go on the bottom to cancel what we have. It'll be 1 mole of C, and it'll be 12.01 grams of C. That's the mass of 1 mole of carbon. For 3 and 4, the 3 is going to be a 1, and we're going to have the 4 as being 2 moles of C, which matches the number of moles in the reaction equation. That gives us number 5, and in this case it means it's 4 divided by 12.01 divided by 2 is what I'd put in my calculator. And that gives me 0.166, which should have 3 significant figures, which makes sense. Now there's no unit on this because the moles cancel, and what we're left with here is a mole ratio. Does anybody have any questions so far? We do something similar for oxygen here. We're starting out with liters of oxygen, or O2, so we know we need moles of O2 first. Liters of O2 will go on the bottom. The relationship there is 1 mole of O2 and 22.414 liters of O2. And then we're going to divide by the number of moles in the reaction equation, which is 1 mole of O2. So it'll be 1 and then 1 mole of O2. So looking at the thing here, we've got 60 divided by 22.414. And I get 2.68. What we're doing here is we're comparing 2 mole ratios. Oops, 2.68. We're comparing the 2 mole ratios, 0.166 for the C and 2.68 for the O2. No units again. And number 11 is looking for the actual limiting reagent, which would be the smaller of those 2 mole ratios, or the more specifically the species that has the smaller of the 2 ratios. And that would be C in this case. So C is what goes in the 11 slot there. Does anybody have any questions? Anybody have any questions? Okay. Right, number 11 is a percent yield problem. Now, it says here, express with unit and compound, for example, grams of zinc. Now, the reason I've got that there and not specifically what I'm looking for is because I want people to understand exactly what they're looking for with the theoretical yield. A lot of the time, people will take a guess and say that you want grams of H2 or grams of Cl2. But what we're really looking for is grams of HCl, and I don't want to give that away by actually saying it here in asking for grams of HCl. It just makes it a little bit too easy, in my opinion. So what I've said is just grams of zinc, but just as an example of what I'm looking for as far as formatting goes, express with unit and compound. So that's really a formatting thing that I'm looking for. So on another sheet of paper, I recommend starting out with what you need here. It says, what's the percent yield of HCl? So that's what you're looking for, is grams of HCl. Whatever you're looking for the percent yield of, it makes sense that you're looking for the theoretical yield of the same thing. So we know that at the end, that's what we want, is grams of HCl. So if we're using our modified flow chart here, yeah, it looks like it did take care of itself, which is really good. We got QA, which is what we're starting with, and what we're starting with is H2. We're starting with a reactant, and that's a good rule of thumb here. With these problems, you always start with the reactant. So we're looking for grams of H2 to moles of H2 first, then moles of HCl will be what we're looking for at this point, and then grams of HCl at the end. So looking at the math here, we're looking for moles of H2 first. Grams of H2 will cancel. 1 mole of H2, 2.02, sorry, 2.02 grams of H2. Then moles of HCl is what we're looking for next. That's over moles of H2 to cancel. The relationship there, we've got 1 mole of H2 to 2 moles of HCl. And then we're looking for grams of HCl specifically, so grams of HCl goes on top, moles of HCl goes on the bottom. And that would be, let's see, 36.46 grams of HCl. And then 1 mole of HCl here. And you might be wondering, well, how do I know I'm looking for grams of HCl specifically? It's because we're told that we actually got 231 grams of HCl. That's what we're told we got. So we have to get apples to apples. So grams of HCl is what we're looking for here. I should have pointed that out earlier. I'm sorry I didn't. So we do the math here. And we've got 50. Do my mouse here, 50. Let's clear this out. 50 divided by 2.02 times 2 times 36.46. Notice I just divide everything on the bottom, multiply everything on the top, ignore the ones. I get 1804, but if I do the sig figs here, it's going to be 1805, because that's going to be 4 sig figs. Although one could argue that that has 3 sig figs, doesn't it? So really, I suppose I'd really have to go with 1810. Whoops. I mean, if I'm going to be real stickler about sig figs, so 1810. I think the answer for this one does accept either 1805 or 1810. So 1810 grams of H2O. The percent yield then is going to be, let's see, 231. That's what we actually got, 231 grams of HCl. Divide by what we should have gotten, which is 1810. And multiply that by 100%. And that gives us our final answer. And that's going to have definitely 3 significant figures. Does anybody have any questions?
So for 1,810, you did everything, but you multiplied, except
Actually, now I think about it, it should be 1800, not 18.
Mm-hmm.
Yeah, 1800 should be, not 1800, because it's 1804, so I have to round it down. That 0 is actually significant. This one isn't. You can't really tell that. Sorry, Michael, was that you who was asking the question?
Yeah, I was just saying, like, you multiplied everything, but you left out the ones.
Yeah, that's right.
So that's how you got 1810.
No, actually, I really should be 1800. I'm sorry, yeah, because it was 1804. If I'm going to round it down to 3 significant figures, it should be 1800, not 1810.
I'm sorry. I've noticed this a couple times when rounding in this class. We don't go past like one decimal behind the last significant figure, correct? Like we don't go like if it's 3 significant figures and it's 104.49, we'd round down.
Yeah.
To 104. We don't even though it's 4.49.
No,
that'd be makes to 5.
That would be double rounding. That's kind of what I just did here as a mistake, Joseph.
Yeah, that's what I wanted to clarify because I made that mistake on a couple of my quizzes.
It's an error. It's an error because you're rounding twice. You're rounding once and you're rounding again. It's like you have a situation to me. I equate it to this, Joseph. It's like when a student gets they're at 80. They're at, let's say, 89.8%. But in that 89.8%, they've obtained like 4 points of extra credit along the way to get to that point. And then they email me and ask me, look, I'm so close. Can you bring me over to 90%? And I say no, because the only reason you got there is because you had all that extra credit. So double rounding is kind of like that.
Okay.
Yeah. It's not, by the way, usually students don't like that answer, but that's the, if I didn't offer extra credit, I'd probably round. But I figure, if you've gotten there, you've gotten there. All right, number 12 is very similar, so I'm not going to do that. But I will say, well, I'll just say what you're looking for here. Again, we're looking for grams of H2O because that's the product, and the percent yield will be the grams of H2O for number 12. Does anybody have any questions about number 12? I don't want to do the whole thing because it's done very similarly to number 11. Okay. Now, number 13 is a module 10 question. I'll leave the Leave my modified flowchart there, just in case I'll need it. Don't need it quite yet. Now this can have there's many possible ways that this question can pan out. There's grams and molar. You could be looking for volume. You can be looking for concentrations. You could be looking for masses. There's a number of different things you could be looking for here. Again, look at the study guide and do the sample module test a number of times, and you'll get to see all the different possibilities here. In fact, remember, it's the same test, so you'll see the same questions too. So, I mean, that's something worth remembering as well. We're starting out with 10.0 grams because that's what it says. Now, what we're looking for is volume, but we also have here molarity as well. So molarity we know is moles per liter. So it makes sense that the first thing we should do is find moles. So we're looking for moles. Now, it does say don't include compounds in the working, so don't do that. Sometimes people do, but I'll give them credit anyway if they email me and let me know, and then I say, oh, that's all right. But I've said not to do it. So 1 mole is how many grams? 58.10. So that's where we're at now. We're at moles. Remember, what we're looking for is volume. So we know the moles have to cancel, and we know in this case that volume has to be on top. And you'll notice what I've done here is I've done liters over moles here. Now, the rationale for that is we know that concentration is equal to moles over volume in liters. So this is that one we have to flip the concentration. So volume in liters is equal to moles divided by a concentration, which is also equal to moles times 1 over concentration. And if you look at that, liters over moles is 1 over concentration. So that would be 1 liter and 0.400 moles. Does anybody have any questions? Now we want milliliters, so milliliters goes on top and liters goes on the bottom. So it'd be 1,000 mils and 1 liter. So that's how we would go ahead and put that in. So for this one, it's probably easier to write it out on a sheet of paper and then type it in as you see it there. Just be careful, make sure it's 1 liter. You know what would also be acceptable here, but the computer might mark it wrong, is if you did, I actually can't argue with this. If people did this, oops. If you did that instead, I could, yeah, I would mark that correct if the computer marked it wrong. I don't know if I've put that in as an acceptable answer. I probably haven't, but if I have not, then you could get credit for that if you were to write to me. So let's see, what are we doing here? Clear it. So 10 is a good example of doing the calculation. So 10 divided by 58.10 divided by 0.4 and times 1,000. Here we go, 430, and it's 3 sig fig, so it'd be 430 dot mils. All right, does anybody have any questions? So number 14 is a stoichiometry question, which is why I kept my modified flowchart here. Now the QA that we're starting with here is going to be molarity, moles per liter, and also volume. So our first step is to get to moles of whatever we're starting with. Now, to figure out what we're starting with, it's actually pretty easy in these problems because I mark A's and B's here, which means that whatever has an A on it, you call A, and whatever you have a B on it, you call B, but that's also what we're starting with and what we're finishing with as well. So that kind of is a bit of a clue there as to how to get started. And it's 1.50 moles per liter of A, which is going to be the KOH. And it's 85.00 mils. So what I was talking about earlier, if we know that concentration is moles per liter. Volume in liters. That means that moles is also equal to concentration times volume in liters. So that means that in order to get to mole of A, I have to take 1.50 moles per liter and multiply it by the volume, which is in milliliters here. But that's going to have to be converted into liters. If I do that, liters goes on top, milliliters goes on the bottom, 1 liter, 1,000 mils. So at this point, that would bring me to moles of A. So let me put those in, just moles of A would be fine there. And I think actually I do have to put liters of A, milliliters of A. For the formatting of this one here. Now we need moles of B next, and moles of A goes on the bottom. By the way, if you don't put these A's in here next to the volumes, and it marks you wrong, feel free to email me. So for this one, it looks like it's 1 to 1, so 1 mole of B to 1 mole of A. What are we looking for? We're looking for the molarity. Okay, so at this point we have moles, which means that in order to get the concentration, the molarity, it's going to have to be divided by the volume. So times 1 over the volume, which is 105.00 milliliters of B, but then we need to convert that into liters. So it'd be it'd be milliliters on top and liters on the bottom. So it's 1,000 and then 1 liter. So it'd be B and B as well. All right, does anybody have any questions?
So the concentration would be 1.50?
I'm not sure what you're asking here exactly. Concentration of what?
For the concentration equals moles over volume and length for the formula?
No, it isn't, because we're talking about at the end of the problem here. To get to the concentration of B, it's going to be moles of B divided by volume of B.
Okay.
But to get to moles of B, Michael, we had to do all of this stuff that's in this flow chart. You just can't see. You can't do moles of A over volume of B. Do you understand what I'm saying?
Yeah.
So you have to do this whole thing here to get to this point.
Okay.
All right. Does anybody have any other questions? Okay. Now for the question 15, if you look at the study guide, there's one of two possibilities. It could be one where you have to find a gas from a list like I have here, or the other one has to do with ordering the velocity of gases. And you have to be prepared for either of those. So again, by doing the sample test multiple times, you'll see both of those kinds of questions, and you'll be able to make sure that when you do see a similar question on the real test, that you'll be able to get it right. But for this one, if you've got grams per liter and you want grams per mole, you multiply it by the molar volume, which in this case would be 0.9 times 22.414, which would be 20.1726 grams per mole. And I think that would be neon in this case. It's whatever matches the molecular weight. That one I think is about 35. That one's 14. Argon I think is 18. F2 would be 38. H2 would be 2. Bromine 2 would be 160, I think. O2 is 32. Kr I think is 54 or something like that. He is 4. So whatever matches that or whatever's closest, that's what you'd pick up. I think it's neon in this one. Again, you can go look at the periodic table if you have any doubt. You have access to it at the beginning of the test here. You can see it there. Neon, yeah, 20.17. So I'm pretty sure I'm good on that one. Does anybody have any questions about number 15? Okay. So now we're into, that's a module 11 question, by the way. So this next one, I would recommend, I think, unless you can do these things in your head, I would recommend writing them down. P1, V1, T1, P2, V2, T2. Let's see. So it says a gas occupies 400 dot mils at STP. So that's all one set of conditions. We're looking for what volume, and that should be V2. That's the answer. And you can see it's listed there. What volume will it occupy at 33 degrees C and 750 dot millimeters mercury? So that should be millimeters of mercury. I should change that. Temperature, it says 33 degrees. So that would be 306 K. So we know, because we're looking for the volume at that, what volume will it occupy at 33 degrees and 7? So all that goes together, and the other bits go together, 400 dot mils at STP. So 400 dot mils is the volume. STP is 1 atmosphere, which is 760 millimeters of mercury. And the temperature is going to be 273 K. So that's what STP is. Does anybody have any questions? So all of that goes in P1 V1 over T1 equals P2 V2 over T2. And we're looking for V2. So if we isolate everything, P1 V1 T2 over T1 P2, yeah. Okay, then we can just plug all that stuff in, and that gives us our volume 2 at the end. Does anybody have any questions about how to do this? Any questions at all about number 16?
For the sig figs of the volume, would it be 3?
Yeah. Okay. The 760, I put in as a counting number, Karina.
Okay.
Because it's a kind of a constant thing. It's 1 atmosphere is that many millimeters of mercury. It's kind of defined as such. Okay, any other questions?
When do you change it from milliliters to liters?
Well, I don't know if it's, well, the thing is that you've got, which says what volume will it occupy, but you're given milliliters, so I think I'd express it in the same unit. Okay. The reason I would do that, and I do have a good reason for it, is when I put this all in, see, I'll show you the work here, 760 millimeters of mercury times the volume, which is 400 dot mils. And that's times the temperature, T2, 306 K. And that's over T1, which is 273 K. And the pressure 2, which is 750 dot millimeters of mercury. per what we have here, the millimeters of mercury cancel, the K's cancel. What we're left with is mils. So to answer your question, you just go with whatever unit you have for the actual other volume that you have, because everything else is going to cancel to leave you that specific unit.
Okay.
Is that okay?
Thank you.
Okay. So there are, again, a number of possibilities for that question. If it did say over water, then you'd have to use this vapor pressure chart, but there was no over water listed here, so you wouldn't use it, but it is there if you need to use it. Okay, so let's see. This is a Graham's law problem. So we looked at this, I think, two classes ago. So a fusion of gas 1 to gas 2, which is what it's asking here, is equal to the square root of the molecular weight of gas 2 over the molecular weight of gas 1. So this is, again, a consequence of the fact that heavier gases fuse more slowly than lighter ones. So that's this inverse relationship. So that's why it's gas 2 on top and gas 1 on the bottom. And it's a square root. So you're given the two molecular weights. Gas 2 is 78.43 grams per mole and 97.11 grams per mole. And that'll give you an answer there. And you would probably stick it to 4 significant figures. There's no unit, by the way, on that one either, because the grams per mole all cancel too. Does anybody have any questions about number 17?
So the answer would be 0.81.
I don't know. I can't do that one in my head. Let's have a look. 78.43 divided by 97.11 equals, and then take the square root. I get 0.90.
Okay.
Can someone else do it, please? Because you seem to get a different answer, Michael, than what I said. You said 0.81, didn't you?
Yeah.
Did I make a mistake? I don't think I did.
I think you're right.
Okay.
You have to use 4 significant figures, right?
I would, yeah. So it'd be 0.8987, right?
Yeah, I was just a little confused when you said 0.9.
Oh no, I was rounding. I'm sorry. I was trying to figure out if I had the right answer or not, and I was comparing it to Michael's, and he said 0.81, and I said, oh, it's 0.89 is what I'm getting here. So.
Oh, I see.
But anyway, yeah, but you're right. You do 4 sig figs, it'd be 0.8987. Yes. All right. So the next one is a electron configuration question. I'm looking for tin. For that one, you want to go back up to the periodic table. And just identify for yourself the S block, the P block, the D block, and the F block. Figure out where tin is. Where's tin? Tin is over here. It's at number 50. So you know where you have to go here to get there. And you always, S starts at 1. S, P at 2P, D at 3D, F at 4F. So that helps if you remember that. So we got 1s2, 2s2, and that would bring us down to beryllium. The P start at 2P, 2P6, down to here be 3s2, and then 3p6, then 4s2. Now the D's start at 3D, so that's going to be here, so it'll be 3d10, and then 4p6, and then 5s2, and then we have to go all the way over to 10, so that's going to be 4d10, and then let's see, 10, 1, 2, so it'll be 5p2. And that's what you would write down, except it would be written in regular text, so it'd be 1s2. And it does say, it does give some directions for formatting here. Just follow the directions. I think it says to put a space between each one. Where are we? Yeah. Yeah. So 1s2, 2s2, etc. It gives you an example of how to format it there. Does anybody have any questions about number 18? Okay, so GeO2, we're looking for the number of double bonds that are present. So figure out GE is in group 4. So let's see, so valence electrons is going to be 1 times 4 plus 2 times 6, so that's going to be 16. So GE, let's see, I'll show you where GE is on the periodic table. GE is in this group here, so it goes 1, 2, and then 3, and then 4. 5 and 6, so oxygen's in group 6 as well. Anybody got any questions so far? So that's 16. So what I do is I do GE, and then I do the O's, connect the O's. That uses 4 electrons. We have to use 16. I'll fix up the O's first by giving them 3 more pairs to give it 8. And then I ask myself, well, I've used 16, so I can't use any more, but the GE is still unhappy. So the GE is going to have to share 2 sets of electrons. So that one is actually going to need 2 double bonds to make it work. So the answer on that one would be 2. Does anybody have any questions about number 19? Okay, number 20 is F2O. We're looking for lone pairs. So F2O, there's no charge on that. Valence electrons is going to be, oops, 2 times 7 plus 1 times 6. That's going to be 20. So if F is in group 7, O is in group 6, it's going to be 20. Then when I do this, the O goes in the middle and the F goes on the outside. And then we'll fix up the F's first, give them each another 6 to give them 8 each. At this point, we've used 16, but we have to use 20. So the other 2 lone pairs go on the O, and there's no double bonds or anything here because everything's happy. So the number of total lone pairs this has is 1, 2, 3, 4, 5, 6, 7, 8. So 8 would be the answer. Does anybody have any questions about number 20? All right. Okay, any other general test 2 questions here?
I have a question on gas velocity.
Yeah.
Can you go over that again, please?
All right, let me see. Who was asking that? I think it was Coden, right?
Yeah.
Give me a second, Coden. I'll tell you what I'm going to do. I'm actually going to see if I can bring up a test question.
Okay.
but it's a crapshoot, you know. I mean, there's some of those velocity questions. There's also some of those molecular weight questions there as well. So it can take a little bit to bring up an example, but I'm hoping with a little bit of luck I'll be able to do that. If not, then I'll have to. I'll give it 2 shots, okay? If it doesn't come up in 2 shots, I'll have to make something up.
All right, thank you.
But I'd much rather see if I can pick one up here. There we go. Yay. All right. So as you can see, number 15, this was the one that could have been the molecular weight, or it could be this one with the gases, right? So the way that it works, and it's kind of like what we were talking about with the Graham's law, the effusion is, the rate of effusion is inversely proportional, means the heavier the gas, the slower it diffuses. It's the same thing with velocity, and for the same reason. I mean, bigger molecules move slower. So what you would do is just calculate the molecular weights of each of these. So neon is 20. It doesn't have to be exact. So it's O2 is 32. NO is 30. KR is, I can't remember. I think it's 80, 54. Is that it? Can anybody tell me what KR is? I can't remember off the top of my head.
I'm trying to look for it right now. 83.80.
Okay, 84. Okay. So it's asking for velocity from lowest 1 to highest 5. So the lowest would be the heaviest one, which would be krypton. And then it would go in that order by the weight. So it'd be 2, 3, oops, no. 3, 4, and then 5. Does anybody have, is that okay, Code?
That makes a lot more sense. Thank you.
Okay, now keep in mind that that could be, it could ask from highest to lowest as well, in which case you have to reverse them.
Yeah.
Okay, as long as you're aware of that. Read the question. A lot of people don't read the question properly.
Yeah, I have sometimes I do that too.
Yeah, just slow down.
Yeah.
Read this one twice. I would definitely do that. All right, does anybody have any other questions about that one? All right, I'm glad you asked that, and I'm glad I was able to pull it up on the test here. But it does show you it's random, you know. You can, and you know what kind of questions you're going to get by looking at the study guide. Okay, does anybody have any other questions? Any other test 2 related questions at all? So as you all know, there will be no class on Wednesday, right? There'll be no class on Wednesday. The test is due that day. You don't have to wait till Wednesday to do a test. A lot of people will. And remember, you can get that extra credit by getting the sample test done and getting 80% on it by 11:59 p.m. And historically, only half the class does that. And I can only assume that those people who don't do it are they just don't like the extra points, or they don't want them, or they don't feel like they need them, or they feel like they have enough, or whatever. I don't know. But I think the main reason is they've left things to the last minute and they didn't want to do it. Anyway, again, if anybody wants to email me, talk about procrastination, tell me why I shouldn't have deadlines, that'd be fantastic. You know, I'd really like to know that. I'd really like to know what people feel about that. All right. Does anybody have any questions? Any other questions? Comments? Anything?
Professor, our next class is on the 15th.
Our next class is on the 15th. Yeah, that would be true. It's Monday after spring break. That's right. There won't be any classes during spring break. I'll send out an email about this, but it's likely that we won't have class on that Wednesday afterwards, though. That's because I'm going to. I think I'm going to take that as a personal time, as a personal day. I'm looking at doing that. And in that case, I'll tell you what we'd go over, and I'll give you some videos to watch. But it would just be that Wednesday. But we'll have class on that Monday. All right. Does anybody have any other questions?
Can you do a problem with molecular weight of the gas?
I just did. You mean I did it previously, Michael? You know, when we had 0.90 and had all that entire list there, I already did one of those.
Okay.
So those are the two possibilities, Michael. That's it. Those are the only two. We did one of one, and then we did this one here.
All right. Thank you.
All right. You can always go back and look at the. You know, I post this. You can always go back and take a look at it.
Yeah.
All right. Any other questions? Anything else about test 2? Okay. Well, we'll leave it there then, and I will see you all. Well, next time I see you will be Monday the 15th. That's right, after spring break. So have a good spring break, and see if you can get this test done before the deadline.
All right. You too, Professor. Have a nice spring break.
Thank you.
Have a good spring
It's
break.
okay, Professor.
Nice spring
Thanks.
break. Thank you, Professor.
Thank you, Professor.
No worries. Thank you. Bye-bye. Jeremy?